Alright, today we are going to be graphing a rational function. So the rational function we have today is y equals 2 divided by x take 4. First thing we're going to do is compare it to the equation for a rational function, which is y is equal to a divided by x take b. From this, we just match up the values. So we have a is equal to 2, and we have b is equal to 4. Noticing that we have x take b as the equation here and x take 4. Next thing we're going to do is we are going to, straight off the bat, draw an asymptote, a vertical asymptote, at x is equal to b. So along the x-axis, we're going to find the point where x is equal to b, which is at 4. I'm going to put my ruler there and draw a nice big dotted line. That is going to represent that we do not have any values of y that satisfy the value of x is equal to b, because that will be undefined, because we cannot divide by 0. Second thing we're going to plot on this graph is our y-intercept. Now the y-intercept is equal to negative a divided by b. You can see this if you set x to 0 in the rational function equation, which would be a divided by negative b, which we know is the same as negative a and b. And what we get there is negative 2 on 4, so we have negative a half. So if we look at our graph, negative 1, negative a half, so we have our function coming in through that point on the y-axis. Next thing we're going to do, we're going to have a look at the number up the top, or our a value. If our a value is positive, I'm just going to write that down, positive, then we know that we're going to have a graph that looks like this. So we're in our first and third quadrants. If we were to have a negative value of a, then our function is going to look like this, roughly. And it's going to be happening in the fourth and second quadrants instead. So in this case, we know that we've got a positive a value, so we're going to have something that looks like this first graph. So we've got two values here that we've plotted in the graph so far. What I want to know now is what is happening to that y value at different values of x. I'm going to grab all this, shrink that. First of all, I'm going to look between my y-intercept and my asymptote, and remember that the x-axis is also an asymptote. So I know that my function is going to get further and further down here as x increases. So what I'm going to do first is look and see what is happening at x is equal to 2. So when x is equal to 2, y is equal to 2 divided by 2 take 4, which is 2 divided by negative 2, or negative 1. So x is equal to 2, y is equal to negative 1. Now, because I'm trying to sketch a curve here, I want to see what's happening even closer to that asymptote. So I'm going to say what is happening when x is equal to 3. So I go y is equal to 2 divided by 3, take 4. I'm going to get 2 divided by negative 1, so negative 2. From this, we do have enough to draw a sketch. So what I'm going to do is attempt to sketch it as well as I can, remembering that we're not touching the x-axis, we're just streaming in, and we're not touching that asymptote. It's going to look something like this. To figure out what is happening on the other side of this graph, what you could do is you could do the same thing we've done here, finding the values of the values of y for certain values of x. So in this case, what I would do is I would say, I know that my graph starts to change when it is at these 3 points. So x equals 0, x equals 2, x equals 3. So I would basically flip that and say, alright, so let's find out what's happening at x equals 5, x equals 6, and x equals 8. You could absolutely do that, or you can effectively mirror the points that you have into the opposite quadrant. So for example, we have x is equal to 3, y is equal to negative 2. So if I flip that into the opposite quadrant, I would have x is equal to 5 and y is equal to positive 2. I have x is equal to 2, y is equal to negative 1. If I flip that, I'm going to have x is equal to 6 and y is equal to positive 1. X is equal to 8, y is equal to a half. And then we can sketch that one again. And we can see that we have got our rational function.